Good day to our evaluators and fellow peers. My name is Nurbatisha binti Nur Azam. My matrix number is AA250257, and today we will be presenting our project report focusing on Pancur, Johor. Pancur is a semi-rural town located along the banks of the Muar River. The local economy here heavily relies on agriculture and freshwater fishing. Because of this tight connection to the river, integrating sustainability practices is critical to preserving both the area's socio-economic stability and its natural landscape. To guide our framework, this study assesses the local infrastructure through three specific UN Sustainable Development Goals, which is SDG 6 for clean water and sanitation, SDG 11 for sustainable cities and communities, and SDG 14 for life below water. So, moving on to the problem identified, through our field observation and site analysis, we highlighted major sustainability issues under two main categories. First, the environmental domain. We observed severe water pollution and surface debris. A significant amount of floating solid waste and plastic debris accumulate along the Muar River due to upstream activities and improper local disposal. Additionally, there is a proliferation of excess aquatic plants, essentially weed overgrowth, which blocks the river channels and disrupt the ecosystem. Second, the socio-economic domain. This combination of floating trash and weed growth severely threatens the natural habitats of freshwater prawns and fish. This has a direct negative impact on the income of local traditional fishermen. Furthermore, local agriculture activities such as oil palm small holdings currently lack sustainable nutrient practice, leading to harmful chemical runoff into the river. To tackle this challenge, we propose an initiative that beautifully integrates physical engineering interventions with a circular economic approach. Our engineering solution is the deployment of a trash boom. These are modular floating barriers that will be strategically placed across key drainage outlets and river curve to trap surface debris before it spreads further downstream. We designed this using durable, cost-effective material so that the local venture community can easily handle routine maintenance. The circular economy side comes into play after the debris is caught. Instead of discarding the harvested aquatic plants and organic river waste, this biomass will be processed into nutrient-rich organic compost. This fertilizer will then be supplied back to local smallholders for their farming. By replacing chemical fertilizers with this organic compost, we complete a sustainable cycle that reduces chemical reliance and prevents harmful nutrient runoff from entering the river system again. That concludes our presentation. Thank you.
Hello and hi everyone. My name is Nufatia Jana binti Johar, number metric AA251204. Alright, so moving on to the chapter 3.0, which is the methodology. To ensure our project is both practical and well received by the community, we executed a stage 3 data collection phase using a mixed method approach. Yes, mixed method approach. First, we use a quantitative approach by distributing structured question digitally via Google Form to target residents to measure how practical our ideas are. So second, to back up our quantitative data, we conduct short direct interview with the chief fisherman and his village and local vendor near the Pekan Pancho jetty to gather real on-site operation and insight regarding the trash boom setup. Now, let's look at our sampling and how we analyze the data. For this study, we managed to gather a total of 30 respondents. We selected them randomly from individuals who frequently use the Pakai Pancho fisherman jetty. And this includes the traditional local fishermen, nearby town resident, and even daily visitor. For the data analysis, all quantitative number from the Google form were calculated using percentage and translate into structured tables and bar chart to easily spot acceptance trends. Meanwhile, the qualitative feedback from our brief interview was analyzed contextually so we could anticipate real-world challenge before actual implementation. So, moving on to chapter 4.0, which cover our finding and feasibility analysis. As you can see from table 4.1, the feedback from our 30 respondents indicate overwhelming community support for Project River Guardian. So let me highlight a few key metrics for you. For question 1, a massive 90% of respondents agree or strongly agree that floating waste and water hastened overgrow heavily disrupt their boat navigation. Because of this major issue, question 2 shows that 18% of them state that a low-cost modular floating trash boom is urgently needed at the jetty. Furthermore, about 55% are fully willing to volunteer and harvest the water hastened for organic compost. And 70% are highly confident that this whole initiative will successfully restore river water quality and improve long-term fish yields. So next, we look into the project's overall feasibility, focusing on the financial and social aspect. From a financial standpoint, this project is highly practical because it relies on a very simple engineering principle and low-cost material. We plan to use deep PVC pipes or even recycled plastic bottle as float for the trash boom, meaning there will be absolutely zero financial burden placed on the local community. Socially, the project has received full approval and a green light from the local fishermen because it directly improves their daily workspace comfort, clears up their boat's pathway, and helps restore river health in the long run. So finally, let's talk about the resources and potential challenge. In terms of material, everything we need to build the mechanical barrier is easily procurable from local hardware store around Pago and Kewasi. As for the organic raw material, water hyacinite is already abundant and readily available right there in the river for our compost production. Of course, we did identify one main implementation challenge, which is weather related. Heavy downpours can trigger very strong river currents, placing high physical stress on the trash boom structure. To overcome this hydraulic stress, our engineering solution is to use an easy to detach modular design, allowing the barrier to be flexible and highly durable. That is all from my session and my group. Thank you.
Assalamualaikum. My name is Nur Anisa Imani binti Mama Amran. My matrix number is AA250088. Today I'm gonna explain for the discussion part. First, we have critical crisis for local fishermen. Navigation issue, 90% of respondents agree and 60% strongly agree and 30% agree that floating waste and water hyacinth overgrow severely disturb boat navigation. The floating plastic and crane trees along the jetty area cause mechanical damage to the boats. For socio-economic, river pollution is no longer just an environmental issue, but it's direct threat to a local livelihood. Next, highly social acceptance. Based on our survey, we got 80% of community support installing a modular, low-cost floating crash boom. This highly acceptance reflect positive alignment with the project financial and resource feasibility. Next, community willingness and compost initiative. Based on our survey, we got 55% total agreement to harvest water hyacinth to repurpose into organic compost. The respondent remain natural like due to the physically demanding nature to harvesting or constraint regarding time, tool, and effort. Other than that, long-term confidence and future outlook. Based on survey, 70 of people, 70% of people believe that Project River Guardian will restore water quality and improve long-term fish and prawn yield. The community confidence exists but must be balanced against the real-world implement challenge. For the conclusion part, Project River Guardian is highly feasible, socially accepted, and economically viable for the Pekan Pancho jetty. Data from 30 local respondents confirm an deniable need for intervention due to floating waste and water hyacinth, severely disrupting boat navigation. Effectively bridge simple engineering with community needs by utilizing affordable local material. For the recommendation, Sungai Panjang community should do regular water quality monitoring. It helps track water pollution and ensure water safety. It also helps local communities live in a healthy environment. Other than that, the floating structures should be screened. The structure should be upgraded to sturdy trash traps, ensure the system can withstand strongly current surge during heavy rains.